So this belongs to a friend of mine, and I said I would sort it out for him. Basically what we've got is a 3-phase motor with what looks like a reduction gear into that bottom pulley, and there's a bearing on the next to the pulley there and a bearing there. So worst case scenario, we can have that gearbox apart there and strip this motor off. Then we've got a flat belt, which I don't like, up there. Keep going to these sets of pulleys. Then we have a gearbox, which is normally a straight through or a 2-to-1, and another bearing, and then a bevel gear, and then down to the quill. That box there behind there, that is the power drive, and unlike the one that I've got in the shed, the Denbigh, and I think this one's a Denbigh as well, but a later model, the frame looks very Denbigh like, and so does the first initial gearbox. But that power drive for the quill is shaft drive, whereas the one of mine is belt drive, but I haven't put any belts on it. So the quill moves up and down, but everything else, this moves, and that works, and that goes into gear, yeah, but this, that's moving there and water's coming out of it. Okay, but that there is solid. So what I want to do is to pop the belt off and see whether this bottom lock works. This bottom lock down there, if that spins, then I know the seizure or the tightness is in that top shaft there, or perchance it's in that drive gearbox. But we've got to reduce it down, but at least the quill's not seized, so that means we can remove that from our calculations. Right, let's have a go. There we go. It could have been just the belt stuck on this, on these pulleys. You heard that sort of removing it, an elastoplast sort of noise. That could have been it. After all, it has been sat outside for a while, which I was not very happy about. Right. Well, that is good news. So now I think we need to go around all the, see if there's any oiling points. Have the top of this gearbox off, bound to be full of water. Take this bit off out the way and oil things up generally. Okay, I've oiled the various bearings. I've got a squeak happening. I think it's in the motor bearings. I might be wrong. Yeah, I think it is. Right, so there's an oiling point there, or looks like one. I'll investigate that, and I'll also show you what the motor says, if we can read it. There we go. Shaft speed 320 revs, but motor speed is 425, which is a standard RPM, 400 volts. So 320 revs. So if we do decide to put a motor, separate motor on here, we will have to put a fairly big pulley on the input shaft, if we can see it. Where is it? There it is, down there behind that cable. Right, well, there are some open oiling points there and there, which is not a good thing because it's been outside. And there's some open oiling points down here, and an oiling point for the gearbox. And I've dropped a bit of oil in this gearbox and also in the bevel gear. And because this belt has been outside, it's starting to fall apart. But I think what we can do is have the motor cover off the end and see what it's like, and we can briefly just experiment with some capacitors to see if we can get this to run. So let's have a look. Okay, just 3 wires. Okay, so if you've seen some of my running a 3-phase motor on single-phase supply videos, you'll know that we will put neutral in one of these and live in the other one, and we will come from the live through a capacitor, and I'm guessing about 60 microfarads for this, to the 3rd terminal. So I'm just going to set that up. It's lunchtime anyway. I'll set that up after lunch and just see if we can get this to spin and bed in. Yeah, if we can use this motor with this about a 3-to-1 reduction, about a 4-to-1 reduction actually, then it will make life easier, and then we'll just have to make up a starter box with a relay, some capacitors and a start and stop button, or is it 2 relays? Anyway, I did a whole video about that, so if I get round to it I'll put a link. So let's just moving on. Okay, I've got that wired up. Just zoom in a bit. Focus.
So we've got live going to this terminal here, neutral to there, and also a link from there down to that capacitor and back to there, and nothing's going to short out. And that is a 50 microfarad capacitor. So we'll just zoom down on that and see if we can get you to see that. That's an AC. There you are, 50 microfarad at, and there's the maximum voltages, and you see it's AC. So let's zoom out of that. We'll plug it in and see what happens. Contact. No, it's just humming. So I think we need some more capacitance. This is where the experimenting starts. Okay, so we've got another 50 microfarad capacitor in parallel with the first one. Okay, so that nearly wanted to go, but not quite. Let's add some more. Right, I've added another 25, so that's 125 microfarads. Seems quite a lot to me. Contact. That's too much. It's made it worse. So what we'll do is, now these capacitors are shorted out through the windings of the motor. So as soon as I disconnect, the capacitors are dead. So we'll just disconnect that, and now we've got 75. Like the way that motor is moving about. No. So, not a lot of success with that motor, and it's because there's a bit of a wind around today, but hopefully we'll keep it out of the microphone. It's because it is a fixed voltage, 400 watt voltage. There's no chance of changing it to 230, 240 volts 3-phase, which means of course that the windings are not matched for the lower voltage. So there you go. It was worth a try, but if it had light duty it would probably run alright. The other thing is, as I was just spinning this over, the belt has started to delaminate significantly, put it like that. And so I spoke to my mate about this, and in conjunction with the fact that there's at least 2 foot sticking out the back of this drill, which is just motor and pulleys, which means in anything less than a very large workshop
it's a bit of an impediment, we're going to go with the same system that I used on my Denbigh drill, with a multi-V flat belt and a motor attached up there, and the weight of the motor tensions the belt, so it'll make it into a lot neater, a lot more usable. So we're going to crack on with that one, and I'll bring you back in as and when things develop. It's another day and we've moved on a bit, and I've stripped out all that motor and pulley system, and also removed this strut that went from the top of the pulley assembly up to a boss just there. 2 bolts, and I've put that piece of 6x3 heavy duty angle iron there. It really is quite heavy duty, and first of all I bolted it central, and then I thought, hang on a minute, that doesn't help, because I think we need, and I'll just get a piece of bar. So we've got a hole there. Now this will be a bigger size bar turned down at the ends, but we wanted the pivot down here for the motor frame, so that the belt, when it came off this big pulley, wouldn't rub on there, and it would come off at about that angle, and that to me looks all about sort of right-ish. I mean, we're guessing here. You could do CAD drawings and spend forever doing that, or you can put things together and find out where the bits don't work. Trial and error. So I think so we needed the pivot to be over this way and down a bit from there. So that's where we ended up. Okay, so we removed everything, and then we have to have the other end of the pivot. Let's just see if we can get that right. So we needed something there, an upright there, then we can weld a tab on that end, that side, to pick up the other end of this pivot bar, and it wants to be inboard of that. So we have a bolt there and a bolt there, so probably, I'm not quite sure, we can have it something like that maybe, and then a bit of bar or a bit of flat. I can clamp it in place and then weld it in place to take the other end of this. So we'll just move forward with that and see how far we go. But it's sort of, you can't rush this, and you've just got to think about it, and then think about it again, and then offer stuff up, and then think about it again. Okay, we've got a bit of flat there, drilled and bolted in place, and further up, wherever it is, we got another piece. So let's have a look. So that goes on the side there, and now I can just clamp it in place, and then when I want to, I can put a piece there to take up the other end of the motor bracket pivot, and that seems to work. And of course it all bolts on, so when I need to I can cut the top of that off if I want, or we can use that for a switch mounting plate or something like that. So I'll just clamp it in place. Might be a bit fiddly, and then I'll probably end up tacking it in place. So this is the quill, and if you can just come round, I can just see that box section there, and I'm just eyeing it up to get it parallel with the two. So we're trying to get that one vertical, and then coming round, I'm not quite sure how to get this vertical. Probably wind the quill down and measure off there and see what happens. So we're going to go from there to there, which is 240, and from there to there is 240. I think it just needs to go that way a little bit. We're coming off this back corner, 240, off the back corner, 240. That's good. And is it still upright? No, it's not. So we want to come out a bit, and then the bottom wants to come this way just a touch. It's a bit rural, but you've got nothing else to work on. And then we'll tack that in place. The only reason that has to be as near as we can is so that when we weld that on with the hole in there, the bar will go in there. Because if it's like that, of course, exaggerated, then the bar won't go through the hole. You'll see what I mean when we get there. So here we go. I put a level on there, which is about the only place that may or may not be level. I could use the table, I suppose. I'll do that, I think, actually. Yeah. And also level this bar up from that. Now that's a bit of 20mm bar just turned down either end. And remember, this unbolts, and that upright piece of box section unbolts. So if I want to take things apart, it's not a problem. So that is the start of the motor mount, and it might look a bit industrial, but no more industrial than a big motor stuck out the back and then some flat belt pulleys and then a huge flat belt flapping around, and it had a wire cage around it as well. So that looks fairly neat, I think, and I think we're about ready to start building the rest of the motor mount. Right then, it's been quite a few days since I did anything on this drill, but as you can see, I've got the motor mount finished. That's just a piece of lightweight box section with bits of inch angle iron notched around it to make T-slots, so they face opposite ways. I spent quite a bit of time on the last video showing how to make that, so I don't need to do that again. And we've got a Brooks Griffin motor bolted on there just for the moment, and a pulley on the end, but the pulley's not really very good, so I've ordered another one. It's been sat outside in the rain at some point in its life, and it's rusted and it's been battered about, so but it's alright just for a trial, as it were. In fact, the hole was too big and I had to bush it out with a bit of rubber hose, just knocked it on there for the moment. However, to get the belt on the pulleys, you have to undo those bolts there on the end of that bearing block, and also, let's zoom out a bit, had to take the top of the gearbox off and the top of the power feed drive off, and undo those bearing bolts there, just to be able to lift that shaft up at an angle. Oh, and I also took the drive off as well, the 90-degree drive. So it was interesting getting in there, just so much different from the drill that I did last time. And of course, last time I put the motor on the other side, and the reason for that was that the gear lever on the one in the workshop is on this side, so it would get in the way of everything. But the gear lever on this one is on the other side, so all the levery bits are all on one side, which is a good idea. So this is obviously a later model, but the interesting thing is that when I took the top off this gearbox, A, it's a grease gearbox filled with grease, and B, it was permanently locked in high gear. So once I'd got the belt on and checked the ratios between the motor and the quill, with it in high gear, it was only 7.5 to 1. So it was held in high gear with the Jubilee clip, because the lever and the fork and everything like that have just gone. It's not there. Somebody's taken it out. Now I moved it into low gear, and now the ratio is 27 to 1, which gives, in low gear, which is on the biggest pulley, it gives just over 50 revs, which is fine for a really big drill. However, that's quite a small pulley, and the pulley I've ordered is slightly bigger, about 20 mm in diameter bigger, so that will just affect the ratios. But I think, even though that is the belt that I had, was coming across a few complications, which if I got a tensioning pulley off an engine for one of these serpentine belts, I could fit the pulley in the right place to prevent this problem, which actually is the belt tends to just rub lightly on that cross member there, and we don't want that. Not that this drill would be running for very long, but we need to avoid that. Either that, or we buy a shorter belt, and I'm going to just inquire how much shorter belts are. But what I'm going to do now is, first of all, I'll just show you this with the motor and the belt assembly connected. So that lifts up like that, and that goes on there. It sticks out a fair way. I think if we had a shorter belt, then the motor could be here somewhere. It's more compact. And then you see it's not quite touching there, but with this one it is, because of course that's lower. Let's just have a look. So move that along a bit. Yeah, it's not enormously a shorter belt would probably just sort that out. Anyway, let's just have a look. I'm just going to move the camera. It doesn't seem to deflect the belt, or perhaps it does just slightly. So So if I was to put this box section extends just to the line of the belt, so if I was to bring a bracket off there and put a tensioning pulley, just the pulley and the bearing there, it would sort everything out. Permanently fixed, just there, and sort everything out. But I really think a shorter belt would be quite nice. We'll just have to see how much they cost. But now the next thing is I'm just going to show you what's happening up there. In which case I'll have to get a ladder out and we'll be on wobbly cam. So there's the bevel gears. And there's an oiling point, which is a little bit odd. Maybe they should have had felt in there at some point. And then there's a really nice spiral gear that mates with that gear there for the power drive. And then coming back, here we go. Initially that dog there was connected there, so this whole assembly was this way, but I've moved it there, so then that gear is connected to, where are we, that gear there, which is a lay shaft, which then comes through and drives this. So there you go. And then we have the pulleys and the end bearing with yet another oiling point. I don't know whether you fill those up with oil or what, but this is pretty horrible grease, and as you can see, this is where the fork would go, but everything is missing. It's not laid in the bottom of the gearbox, is just missing, been taken out at some point. So there you go. So this is a low speed drill now, and if you wanted to go to high speed, you have to take the top of the gearbox off and move this gear, slide it that way, and then tighten up this Jubilee clip which holds it over there. Hopefully that makes a bit of sense. So we're moving on quite well, and in anticipation of adjusting things for the belt, I've chopped the corner of that initial big lump of 6x3 angle iron off, just so it's not poking out, and if the belt goes all the way across there, it's not a problem. So now the thing to do is to wire that motor up and make sure it's spinning the right way, and if it's not, I did a whole video about that as well. And we've got something flashing on the camera, so I'll stop. Okay, I've roughly wired up the motor and put about a 7/8 number 3 Morse taper drill in this quill, and mounted a bit of steel plate with a pilot hole. It's about a 1/2 inch pilot hole. So let's see if it goes the right way, and if it doesn't, then we'll have to change the rotation, and B, how it drills and whether or not it transmits enough power. That is a 3/4 horsepower motor at 1425 revs. So let's give it a road test, shall we? Contact! The motor's jiggling around, but we know that pulley's not very good. But let's just see how it drills. And that drill is going round mighty slowly. Let's just zoom into that. So one of the design things I'm thinking about is we've got to avoid that rubbing on there, and we don't want the motor like there relative to the pivot. I think it's a good idea to have the motor this side of the pivot, if you get what I mean. And the motor isn't the shaft side of the pivot, it's the opposite side, so the weight is pulling away. So, to avoid that, we could have a pulley like that there. And that would do. So it's a matter of making up a flat plate, tacking it in place, making sure it's all in line. And of course, this will be fitted to this frame. So as you move along, the whole thing moves together. Fair enough. But the motor is still stuck out here a bit, although it's rocking on the base because the concrete's not flat, but it's still stable enough. And I just wonder what would happen if we raised this pivot bar up to say here and moved it in a bit and had a shorter belt. Well, my mate came up with a shorter belt. It's the same as this one. 1, 2, 3, 4, 5, 6 ribs. So if it was there, it would just change things a bit. It would move the motor further in there, and if we can get the motor to raise up a bit, then it will avoid that problem. And this would be good enough, and if I was in a rush I would just mount the pulley there and have done. But when this has gone back home, then we've got no more room for experiment. So the time is now. So we can have a go, and what I propose to do is just in the interim clamp a bit of steel on there with the right hole and clamp a piece of steel here. Can't go there. Let's use a bit of the wrong size, but a bit there. And just clamp them in place, and that way we can adjust it and fiddle and see what happens. We just, you know, it's a trial and error again. This works, but it's not perfect. Hopefully if the motor was further in and slightly higher up, then it would work with this shorter belt. And this belt is about 40 centimeters shorter than this one. So let's see what happens, shall we? Okay. So, where are we? I've extended that up there, but I haven't cut this bit of steel to length yet. And we've got the shorter belt on there. And let's just have a look at the other side. If we can just see, we can. And as you notice there, I've got the switch in place. there's the other end, and it's raised up quite a bit. There's the bracket last time, so it must have raised up at least 6 inches. Yeah, and that piece of steel there needs to be longer, so it's it will overlap on that piece of inch box section there as much as it can. But if we look on the other side yet again, so we can see the belt, here we are, here's the belt. We've now got a gap there, and I think if we raise these up another, say, ½ an inch, yeah, and we've got a decent angle on this mounting, so it's not as if the belt can actually lift the motor very much because it's fighting against this pivot. I think we're nearly there, and I'm much happier with that, and that is just for, I don't know, 20 minutes of messing about. So I'm just going to back off now, move the camera, and we'll just fire it up just to see that everything's about right. So the clamps are tight, it's plugged in. Right, I'm a lot happier with that. I think if we can just weld a piece across there just to keep those stable, and raise this pivot up just a bit more both sides, it'll be a lot better. I think the next thing to do is just to move this along to this pulley and make sure that we've still got a gap underneath that belt. So I'll just do that. So now we've got a design flaw there. So what I'm going to do now is adjust the motor so that that belt there clears the mounting bracket, and it may be, well, we shall just have to see, it may be that we won't be able to move these up any further. So let's just try that. I've changed that, so we've got a gap there and a gap there. So we'll lift the motor and slide it along and drop that down. Ah, yes, we're happy with that. That's pretty good. Yeah. Right, what happens if we're on this belt pulley here? Lift the motor, slide it along, put it on the smallest pulley. I think we're going to be, oh yeah, just so the motor can come down just maybe ½ an inch on these slots. That is clear of there. Yeah, we're a lot happier with that. It's just a very fine tolerances here. Let's just switch it on. We're still recording, we are. Brilliant. So the motor wants to come down a little bit more, ½ an inch or so, and we're happy at that. I can mark this up and cut it off and weld that in place. This end I'll have to make a new one just to give sufficient overlap. Although I suspect that will be fine there. Just wants to be upright a bit more. That just, yeah. put it on the slowest speed. And there we go. Excellent. That can afford to come up just a little bit like that, which is why the motor will come back and it'll lift things up. But that'll be grand. Worth the effort. So I'm going to crack on with that, and I'll come back to you when I've got it all in place. The bracket down there, where are we? That one there will obviously get ground off, or perhaps I can leave it there as part of the R&D, but I have to go around all these corners and just smooth them out a bit. Okay. So as we can see, we've got enough gap there, which is great. I've welded that tab on there, and this end I've bolted it on, just so if I want to adjust stuff I can make these holes in this plate bigger and it can pivot around. And there we go again, you see there's plenty of tension on that belt, so that'd be grand. So that's taken quite a while. I mean, if all the hours were added together it would be sort of less than a day probably, but there's a lot of thinking time, as I've said earlier on. Thinking, trying it, that's not right, find something else, because we're using what we've got. We're not sort of building a buy list and then going off spending a fortune on this, that and the other. We're using recycled materials to recycle a very delightful pillar drill, and now it will drill big holes in big lumps of steel. So hopefully you've enjoyed this. Please click like and subscribe, and I will catch up with you soon for the next interesting project. Cheers for now.